Recording session of this. Okay, if any kind of a window, suppose you have this window, by mistake I've just closed it. For some other window, it is not coming or it is not visualizing over here. In that particular cases, you have to see X, Y, Z. These are all the main things that we are using it to just visualization purpose, right? So it is available in the view module. So you just go to the view. Inside the view, you have a toolbars, and these are all the toolbars that it will be available. Now you just behind this views, tick mark is not there, right? So you just click on this views, then automatically the views window will come. Now you can drag it and drop it that wherever you want it, it will fit into that particular window. Like this, you can able to set it up. Okay. You have to go to views. Inside the views, you have an option called as the toolbars. Inside the toolbars, you have an option called as the views. You have to switch on this views, then automatically it shows up. Is that clear?
Yes, sir. Yes, sir.
Okay, fine. Yeah. So in our last session, let me go to the documents and Unit Essential. Here we are solving this abacus solving, and so on so date that we were trying to do something. So this is where the sections are. So just copy this one path. So file, set working directory, or if you don't want, like you can just open this particular file directly also. This is where the file that we have opened it directly. Okay, if today that we are doing all these particular changes to a different folder, right? So what I can do, I can just go here. I'll set this working directory, not this one. So today's folder is this one, right? So I'll just mark it this. So now whatever the things that I am doing it in today's folder, it will save. All the things will save it in today's folder.
This we have one doubt. So actually, when we were assembling all the three parts, so it was merging with each other. So when we were separating it, it was not. We were not able to separate it properly. So how to do it properly, merging and properly, how to do it?
Can you increase your voice a little bit, because I can't hear you properly?
Sir, I was feeling like when we were assembling the three models, like plates, that beam, and something like that.
Okay, when we are assembling these three models.
So it was merging with each other. So when I was trying to like separate it and get it at exact position, it was not coming through. I don't know why, but
when you are trying to separate this one, you have to do. Okay, in your practice, you got it out. That is what you are trying to do, right?
Yes, sir.
Okay, fine. I'll show you that also. Go to assembly instances. Now all these three I would like to delete. Okay. First, I'll go to create create an instance. So I'm just selecting this as my bottom plate. So okay, I just brought this particular bottom plate. Okay. So now this is that the coordinates is also available. Now if I just go on to this any kind of the views, now you can see this one. So this is at the top and the positivity is going on. Okay, so this is what actually we got it. Now I would like to bring one more instance. So that one more instance is nothing but my middle bar. So I'll just give okay. Okay, so whenever you just see a perspective view, then you can just click on this turn of perspective view, then automatically it will come back. Okay, now actually what you are trying to do is like when you just try to rotate this particular part, these two are merged with each other. Now you want to separate them. To separate them, actually what you can do, select this, first click on this translate instance. Once you click on this translate instance, then it will ask you like select the instances to translate it. Now this was the instance that I would like to translate it. Okay, just give okay. After giving the okay, then you can say this one. This is the region completely, it is merged. It is top region, it is completely, it is merged. That means this is complete thickness, it is merged in this. So I can say this from starting from this point. Okay, so I would like to choose that as a starting point. Now select an end point. So this point I want to replace to this point. So then automatically this instance it has been moved. Okay, but if you don't want that one, you can always do a control Z. You can select this particular things. Now you can choose this one. This is my start point and this is my end point. So now you can choose this one. Once if you select this particular thing, then automatically it has been done. After this, you should give okay. Position of an instance, you should give okay. Then only it will freeze that particular position. And you have to click on this done.
Sir,
Yeah.
sir, how can we place it at its correct position wherever we want to?
Where you want, you have to play with your coordinates only. That's it. So now tell me where you want, I will tell you the position.
Sir, okay, if we want this beam at the center, okay, of
Okay,
this.
okay, fine. So for this, actually, what I try to do first, if I don't know the dimensions also, I have an option called as a query button here, over here. This is called as a query information. So this is available over here. So you just click on this query information. Now click on the distance. Now select the distance from here to here to the midpoint. Exactly, it is 11.25. Or else from here to here, it is exactly 22.5. That was the distance actually we have it. Okay, so and if you just measure this particular distance to this particular distance, so this is at a 7.5 actually. This is at a 7.5. So now to this particular position, I want to move a little away of like a 11. If you just consider it as 11, and this is around 7.5, so it's a 3.25. So 11 minus 3.25, it would be like around 7.58 that we can manage that. So see this one. I'm just trying to do this. Okay. Okay. After selecting this, okay. Now you can do this one, like how much that you want to translate it. Go global coordinate systems, it has been selected from 0 and 0, 0. Select an axis on the start point of your translation vector. So I can choose this one and I can choose this particular point. So it is exactly, it is shifting over. Okay, just give okay, no issues. What I try to do, I will try to add a point in between these two. So I'm just going this. I try to add one more point in between these two. Now I'll click on this translate button. Now this is my start point and this is my end point. So I'm just give okay. Okay, suppose if you would like to move on this particular side also, you can go and choose this. So in between these two, I would like to add one more point. So the translate button. So this is the object I would like to translate, and this is my first point, and this is my second point. From which point to which point that you are trying to translate it. This is how actually you can able to do this. But if you have a dimensions, like from this particular phase to this particular phase, I would like to maintain this much of a distance. And again, from this particular phase to this particular phase, I would like to maintain so much of a distance. If you want to do those kind of a things, then you can go, it is like a parallel constraints, parallel face-to-face constraints and all. So you can just go here, you can click on this and you can click on this, just give okay. So these two will act like a parallel in conditions. Then what you can do whenever you want it, you can also create a coordinate systems as you know the coordinates. So I would like to create a point. So I would like to create a point at 15, 0, 0. If you just set 15, 10, 5. If I just want to create a point, then you can see this automatically another point it has been created. So the new point it has been created. As per that particular point, you can able to do that. Okay. Suppose so from that particular position, you can able to make an instance of it. Now this is 11.25, right? So when I just go this is on the x-axis how much I want to go. Distance from here to here, the distance is 57.5. So when you go with the dimensions, so 57.5 by 2, and you can create a point that wherever you want, you can start your position and replace that particular point to that particular position. Okay, like this, you can able to translate it. And you can able to give always a face-to-face constraints also. That is where like this is a parallel faces constraints, and this is a face-to-face constraints, and this is a parallel edge constraints, similar to that. So okay, based upon all your projects that we can able to identify that one. This is where a rough I'm just showing you all these things. But if you have once done the once if you can give me the cross-sectional profile of your project, and we try to generate the same over here so that it will be helpful. The same part will be helpful for you in the project design also. Okay, so now after this, so what I try to do today is, so you know the part module that we have created a bottom plate, we have created one eye section, middle bar, top plate, and even in the eye sections that we have used some options to remove the materials like that. So now we try to see whenever you wanted the part that which I've created, if I want to manage it, this particular part manager will help you for this. So click on this part manager, and these are all the parts that we have created. Suppose it is not a 3D deformable, something you want to change it. So you can just go. You can rename this particular part. Whenever you want it, you can able to rename this particular part. So again, in the part, if you just go for this middle bar, and I would like to edit this particular middle bar. If I just go and right click on edit button, then instead of 3D, TD planar, if I want to make this as a rigid body also, I can make that as a rigid body. So like this, whenever you want it, you can able to change the properties of your part. Okay, the now once up to the part it is created, once your part is created, the very important thing that we will see today, like how to assign a material properties to that particular part. So okay, so just before that, there are multiple options over here. This is where like create an extrude, revolving solid, and about a sweep line that I would like to do this one. So once if you click on this, so it's asked you like to create a sketches about which that you want to do this. So now I just click on the sketch. So now what I do, I try to select this particular plane and I will select this particular face. So now you try to understand it very clearly how it behaves and all. So I am trying to do something like this. Done. This is what is my sketch. So correct position only. And now I just want to do the profile. So click on this line and plane type, you just specify it, or you can auto calculate it also. Auto calculate also, it will take it up automatically. Okay, so you just go automatic and take any of the plane that which is possible, then automatically it will try to take it up. And now on this particular profile, I would like to create one kind of a spline or like a tangential points or like a line also you can able to do this. So I would like to go like this. Excuse me, guys. So I just want to do something like this. Something like this. Just give done. Section must be closed for this. It should be an open profile one. One second, guys. Yeah, you can just go for this, and this is a path. Sorry, in path I'm doing this. Okay, in the path I can select this line. So create a tangential arc spline.
Sir.
Yeah, please. Hello.
Sir.
Yeah. Tell me. Hello.
Sir, your voice is fluctuating a lot.
Now is that clear? Hello.
Yeah, now.
Is it better now? Hello. Hello.
Yes, sir. Yes, sir.
Yeah, let me go for this. So I've just created a particular spline. Now pick a start one. Like I've just created this particular spline. Done. About this particular path, I would like to do one particular profile. So the profile, I would like to go for an auto calculate of this. I can choose this particular path. Okay, that's perfect. So now I try to go this particular shape over there. Done. Okay, now once I just give this particular things, now you can see this, how I can able to create this one. So I have created a new material that which is along with this particular path on this particular part. So later on, I can able to adjust this. If I want, I can able to translate this or something, or like in the features also, I can able to do this one. So go to the features, solid sweep, like now this is a section sketches, right? So now in the section sketch, you can just say from here to here, you can make it as 0. Okay, the profile it is coming back. That's why I always told to keep it there. No issues. Like in translate options that also you can able to do this. Otherwise, you can do one thing. You can choose that as a path exactly. Section must be self-intersecting. Okay, there are some points actually it is coming over here. Like this, actually, you can able to generate this one. Like I try to show you on the other side. Suppose in the same way, if I want to remove the material also, I can able to remove the materials. So those are all the things that you can able to do it here. So create a cut sweep and all. So now I'm just selecting this. Now again, I should draw a path. I would like to do the path over here. I would like to do the path over here. I can select this one. I can, here it will ask you every time like select an edge or an axis vertical line or the right. So you can just select this particular line. So now we can go here and we can draw the path. I'm sorry, like. Okay, so you can do this one. Later on, I just need to choose a profile also. So I can just click OK and go to sketch. Now this is auto calculated. Vertical edge is this. And now instead of this, we can go as a circle also. So I'll just show you the difference. Okay. So now just give OK and then just give OK for this one. Now see this one, it has been completely removed as like a circle once. Now see this one, it has been removed completely as like your profile surface. So even in your problem also, whenever you want it, you want to insert your beams or rods with different cross-sectional profiles, or if you want to bend those particular things, so simply you can able to add here and then you can able to do it right. Okay, so this is how you can able to create the profiles. So for Ashish project, that what I have as an input. So this is more than sufficient. This is more than sufficient to do the project. And then FRP, still I need more clarity on an FRP from Ashish, so that then I can teach you like how to do this. Okay, now we'll just go to the property module because we need to assign a material to this particular thing. I have like a bottom plate, I have an eye section, middle bar, and top plate. So there are multiple options are available over here. So now I would like to create a material. This it's just a cross section I have told, right? Now I just need to apply a material properties to this. I need to tell this has been working, this has been applied with some steel, or this has been applied with some concrete, or this has been applied with some aluminum, or this is some carbon fiber. So I need to tell to the software that this has been assigned with a material. So to assign a material that we will use a property module over here. So inside the property module, you have a create material option. So click on this create a material. Then it will ask you like what is create a material that you can add here descriptions. So you can description like your so and so project and so and so from website. I got this particular material information like that. You can add a descriptions over here. So after adding up the descriptions, now you can go to your general and click on your density. So you have to go your general and you have to click on your density. So density is nothing but by mass by volume. So we have to give to calculate your weight of your software. To calculate the weight of your part, you have to feed this particular density. So now let's say I'm just going like steel, which is a 210 GPa, 210,000. That is what 210 MPa that is. Sorry, 210 GPa is Young's modulus. So I can just go it is 7.85 e to the power of -9 tons per mm cube. As we have discussed in our last session, if you just remember this, all Abacus doesn't have any inbuilt unit systems. You have to follow the default unit consistency throughout your particular problem. This is what actually in our last session that we have discussed about. So as per this, I'm trying to model this in mm, and I'm trying to model this in an mm, then we can see this density is fed in terms of like a turn per mm cube. Density is fed in terms of like a turns per mm cube. So here I have given a density is also in terms of a mm cube. 7.85 e to the power of -9 turns per mm cube, or is 7850 kg per cubic meter. Okay. So 7.85 e to the power of -9 tons per mm cube that I have fed. So just give OK. After giving that as an OK, so now a new material it is created. In the material manager, you can see this. This is the material. The new material it is created. Now to the created material that what I have done, I have to assign that particular material to this particular part. To assign that one, actually what we can do is like create a section. So in this particular section, this particular geometry belongs to what I need to tell. It's a homogeneous in nature, or it's a generalized plane strain model, oil area, or a composite. So in our most problems that we use are homogeneous in nature. Homogeneous is nothing but wherever you see either an X direction, Y direction, or Z direction, or any point if you pick it, the material properties will be uniform throughout the section. Throughout the section, the material properties will be uniform. Those kind of things that we call it as a homogeneous in nature. Those kind of things we call this as a homogeneous in nature. Okay, so generalized plane strain and oil area that we are not covering here, and the next one is called as a composite. So once we got the composite details that we will see. So for the time being, I'm just trying to select this as a homogeneous, and this is for solid part of it. This is for 3D. If it's a 2D, I need to select as a shell. If it's a 1D, I need to select as a beam. If anything others are there, then I have to go for others. Okay, others in a sense like a gasket, cohesive elements. Cohesive elements is nothing but your epoxies. Okay, so to define those kind of things. So we'll first finish this like solid. Now in the solid, I would like to select this homogeneous in nature. Click on continue. Once you click on continue, then it will ask you like what material you want to apply for this particular profile. So material one that which I have created it. So it's done. After doing this, then in the third option that you have an assign section. The third option that we have it called as an assign a section. So click on this and assign section. Click on this and assign section. Now select this particular part, and name whatever the section that you wanted. I can say this is the top plate, right? So I can just name this section also as a top plate. Just give done. So after giving a done, this is where the section 1 I have created it. I would like to apply this one. So the moment when you apply the material, then the color, it will change automatically. So the moment when you try to apply a material, the color will change automatically. Now, if you want to measure the weight of this particular part, how much it is. So you can go to query information again. Now you can click on this mass properties for this entire part. Just give done. Now here it will show you this. This is 5.08 e to the power of -5. That means tons to kg if you would like to convert this. So 5.08 e to the power of -5. That is nothing but 0.0508 kg cities. If you would like to convert this as a grams also, you can able to convert this. Okay, 5.08 e to the power of -5. That is 50.8 grams. Now, what you have to do is like once you have created a material and assign a material properties, first thing is like you have to measure the weight of your part. After measuring the weight of your part, and if you feel that the weight of your part is correct, which is realistic in conditions, then you can proceed further with the problem. Otherwise, if your weight is not constant or if your weight is something unrealistic number, it is there, then you have to little worry about the unit systems. Okay, then you have to worry about unit systems. For example, I'll show you here. Now I'm just going here. Instead of properties here in the material things, instead of 7.85, I'll just say I've given it in terms of like cubic meter per second. Sorry, kg per cubic meter. 7850 I have given it. So once if I give 7850, it has taken it. Now when I'm trying to measure the weight of my part, now it was saying this is what actually is. This is what the number of kgs a model can have. No, right, which is not at all a realistic number. Okay, so that's why we have to make sure that before what we got is 50 grams is like more acceptable one. So you have to maintain the particular unit consistency throughout. How to create a material and apply the material, you got an idea?
Yes, sir.
Okay. Okay. So now the material, it is applied. Whenever you want, you can see all the list of materials over here. Whenever you want, you can see all the list of sections over here. Whenever you want, you can able to see which kind of a material it is applied for which part. Okay. So once after finishing this, you are going to assembly module and then you go for assembling of all the things. As if I change some of the geometries over there, but it is not reflecting here. So always just go this features or click on this features and regenerate, then automatically it will regenerate the things. If any changes it has been applied for any of the other parts, then it will do it. So like this, you can able to click on this, you can import each and every part. Okay, you can able to import all these particular parts. Next important thing is called as a step module. So in the step module, before getting into the step module, I want a clear-cut problem statements of yours. So today, I'm just stopping the class over here. I request you to make these particular things. So I can share you these informations. So I need these informations to proceed further on your work actually. So geometry of your project, detailed dimensions I need. Material information with grade name, forces to be applied, outputs expecting. If you want, please take a screenshot of this, guys. So you have to get back to me with these particular values, then only I can able to help you out with the trainings, because this is a project oriented
Yes,
training.
sir.
Okay, so I need this particular, all the informations you can make either PPT or like a OOD. I'm giving you the time today, then only I can able to talk like which kind of analysis that we have to do. And based on that, I can able to teach you about like a step procedures and all. Once we create the step, then other things and all, we are going to create it in a flow. So I need these particular things. Once of you, from all of you, if I receive these three particular inputs, then only I will proceed for the training for the next session. So today also we have almost all 1.5 hour of a time extra still that you have it. So please try to rework on this and share me to my email IDs, then we can start with this. So once if you can send me this, most probably for everyone, you might be having multiple steps over there. So just go and create this. So there are multiple things, either in linear or general or linear perturbation. Linear perturbation, these many number is there. In general, these many numbers are there. So which analysis I need to choose just by seeing in detail about your project, then only I can able to tell you that. Based on that, we will be discussing about the Newton Raphson method and central difference method. Once if you can provide me those particular informations, then we can see that. You want me to wait, or like you guys can provide me? Now today you have learned like how to create a material just with a density in the general density that you are creating it. And then after creating that material, you are applying that particular material to your part, and you are measuring the weight of this particular part. And then you have to realize whether my weight is physically it is matching with the physical weight or not. If the physical weight is not matching with this, then there is something you have wrong given in your unit systems. So you have to rectify those particular unit systems. Is that clear, guys?
Yeah, exactly.
Yes, sir. Yes, sir.
Okay. So then I need this input from you. Only after this input I will start.
Sir, I have sent you some mails regarding my projects, some of the composite sections and themes.
Ashish, regarding no, it is not
Team
about the
animation
papers.
material.
It is not about the papers. Papers is good. That will be helpful for me. But the thing actually, I need to be put it in a Word or a PowerPoint presentations with these particular 4 steps. If I say material informations and all, then you should show me all the material informations as one slide. Geometry related things was one side. What are the types of forces that you are applying it? What are the types of an outputs you are expecting from it? Like this, I want presentation.
So give us today. We will make it tomorrow. Is it okay, sir?
Okay. I'm giving you the time today. So today it was by before tomorrow session. That means morning around like 12 o'clock. Before morning 12 o'clock, can you able to share me these things? Tomorrow
Yes, sir.
morning?
Sure, sir. Yes, sir.
Okay, please share me that. Then I can decide like how to proceed for the remaining parts of the training. Then I can able to explain it. Because Abacus is not a very small software. It's a very huge software. As I'm working with an Abacus from last 9 years, still I can say that confidently that I don't know some of the parts of Abacus. Because it goes on like a hell. I'll show you this. This is only a step. In properties, I want to say that if I just want to create a material, so I just do this. I've just explained you only the densities. Then what is D-vapor, regularization, user material, user defined fields. So if we go for mechanical, you have an elasticity and these many elasticities are there. If we go for a plasticity, these many plasticities are there. Damage for ductile materials, these many damages are there. So traction, these many things are there. So you go for like a thermal, you have